we're very interested in the complex relationships of the different units of the Trinity Aquifers and understanding how rainfall eventually becomes discharged to Jacob's Well, or how much is flowing down gradient into deeper parts of the Trinity Aquifer, and also how much is flowing in the creeks, because ultimately some of this water from this area flows over the Edwards Aquifer and recharges the Edwards. So this is very important for water resources, both the Edwards and Trinity.
With the installation of a second groundwater monitor well near Jacob's Well in Hays County, the district will be able to gather information about the lower and middle Trinity aquifers.
This was more of a standard monitor well into the Cow Creek. So we have drilled like a 8-inch borehole into the Cow Creek, and then we've sealed that off from above. So now we can go back and take samples directly out of the Cow Creek or measure water levels in the Cow Creek there. But we've also installed a piezometer into the lower Glen Rose. So as we were sealing off the well, separating the Cow Creek from above with the cement, we put in some gravel pack and a PVC tube in which we can measure water pressures.
The Cow Creek limestone makes up a portion of the Trinity Aquifer and supplies groundwater to numerous houses, ranches, and businesses. Drilled to a depth of 280 feet below ground surface, the well is being used for measurement of water levels. This will provide a good indication of the status of the aquifer.
So now when we go there, we can measure water pressures in the lower Glen Rose and compare those to water pressures in the Cow Creek to understand the relationship better of the shallower lower Glen Rose to the slightly deeper middle Trinity of the Cow Creek formation.
As the well was drilled, we cored it.
Meaning that we get pieces of rock, because normal well drilling will just grind through the rock and you get little bits of cutting like we see at the surface around here. And you can tell a certain amount about the lithologies and the geology from that, but it sure doesn't beat having a solid piece of rock like this piece of core at a depth of 204 feet. So this is part of the limestone, and if we look at the log from that well, so this is a geophysical log of the well, in which on the left is gamma. This is measuring natural gamma in the formations and showing when the kicks go to the left, it's more like a good clean limestone. And when they go to the right, then they're getting some clay, shaly, more detrital, sand and silt material in there. And that's a key difference in how water would move through. Or water can move well through a reef rock like this, but then when we get this here with clay in it, the water isn't moving very well through there.
These solid pieces of rock are filled with historical information.
Now, as I mentioned, this is one of the cores from 204 feet, and it's not very permeable. You can see that the kicks and the gamma are going a little more to the right, but this one is from 74 feet. So this is here in the heart of this reef, which is actually a rudist reef, and rudist are a type of clam, and we see the remains of one of these here. So it's a special clam that grew some very elongate shells. And much of that's been dissolved out and leaves this pore space. It's good for storing water and transmitting water. But this is the reef rock, and this is more of a finer limestone it's in shallow water, but it doesn't yield as permeable as a rock as this does.